Okay, this video is going to be dealing with last week's activity. Now this is the first activity that you were given. I just want to have a bit of a video travelling through how you find the finished solution of this for anyone that was a small bit confused or not even too sure if the solution that they've submitted is correct. So for the first activity here, what I would do if I was you, I would go up here and I'd look at what the question is being asked. Especially in this conics, it's very important to see what's being said here, what information you can use, and also identify each of the bits of information that you've been provided in the diagram itself. Now this is a semi-completed question, so as you can see here we actually have points on the end solution, such as point P here. We have our directrix, we have our axis, and we also have our tangent. Given the directrix, okay, so we have that DD, the axis, our axis here, our tangent there, to a parabola. Okay, so that's very important. We're dealing with a parabola. Point P is a point of contact. Draw the parabola. Okay, so I know we're dealing with a parabola. So first of all, I know that I can draw a line off here from my eccentricity. That's at 45 degrees. Because remember, my parabola is always going to have an eccentricity of 1, which is going to be 45 degrees. An ellipse has less than 1, so it will be an angle less than 45 degrees here. This is all stated in the graphics book. And if you're dealing with a hyperbola, it's dealing with an eccentricity above 1, so it'll be more than 45 degrees. So I'll just have my 45 degrees there for my parabola, and I have my eccentricity line. Now I already know that I can use eccentricity to complete this question to some extent. That's my 45 degrees, and this is my ECC line, short for eccentricity. Now also, I need to identify where my focal point and my vertex are, okay? To do that, I can use my point here given to me. I know if I have a look at my graphics book as well, dealing with eccentricity, there's actually a bit of a formula. So this is my parabola here, this is the eccentricity method. So the eccentricity is equal to the distance from the focus to a point. Okay, so that's a point on the curve. So from the focus here to a point on the curve is the same as a point to the directrix. So this distance here, so let's say from this point of the focus out to, let's say, this point here, is the same distance as it is from here straight back to the directrix. Okay, so F to P, same as saying P to DD, which is the directrix. So that means if I come back here, I take the distance from P all the way back to my directrix DD, like so. So I take that distance and I mark it off here where it hits the axis. That is where my focal point will be. So I can draw a line from my point P through to where that arc intersects the axis, like so. And now this point here, I can call my focal point. Okay. Now, another bit of information. If you have your focal point and you want to find your vertex, what you can do is go at 45 degrees from the focal point, where it intersects, or where it hits, or intersects the ECC line. If you drop a line perpendicular to the axis down from that, you have now located your vertex. Now that's important construction there. This works with all conics. If you have a focal point and the eccentricity, you can find your vertex. If you have your vertex and your ECC, you can do the same by going up and coming back down at 45 degrees. So it can work both ways, if you get me. Now also, if you went off in 45 degrees up in this direction, where it hits the ECC line and then drop down will be your second focal point. But when you're dealing with a parabola, these lines are never going to meet because that's already at 45 degrees, and if you go up 45 degrees here, it will never hit off it. So there's not going to be a second focal point. If you're dealing with an ellipse, this was less than 45. When you go to 45 here, it will intersect at some point. When that's dropped vertically down, then you'll find your second focal point. So now we have all the information we need. We have our focal point, we have our vertex, we have our directrix, we have our ECC line. Now there's actually a variety of methods that we could use here to complete it. Just to keep it simple, I'm going to run with the eccentricity method. I'm going to draw my focal line. It's just a perpendicular line from the axis traveling through the focal point. Extend it like so. Also identify what it is. Now again, I don't write much annotations here. I just identify key bits of terminology. The reason I don't is because I'm talking through it here. For ye, ensure that you have everything annotated. If you're talking about how you found any particular point, let's say like the focal point, write in, put arrows, put little arrows where the lines are coming from, for instance, saying that this is going back that direction and then this is going at the same distance. Let's say this one is back here. All that stuff is important to identify in your drawing itself, so that then when you look back at it, you can deduce from what happened. Now what I can do is start drawing lines across like so. Just going to break it up. I'm just going to do a portion here so you get the point. Few lines. The more lines you use, they don't have to be a specific distance, you can just do them randomly, but the more lines you use, obviously the more points you have then on the curve itself. I just like to do a handful and do it freehand just to show that I know the actual construction itself. You get your compass, you extend it from the focal point out to where any of these lines hit the focal line, and then you scribe your arc. That's 1 point, another point, that's another point. Now we know that's going to hit here where the focal line passes through the eccentricity, so I'm just going to identify that as a point as well. This point, this point, this point. Also get the one this side between the focal line and the vertex, which is actually going to be very close to the eccentricity line but not on it, and then it's going to sharply come down to my vertex. Now I'm going to try to do as best I can my freehand curve, trying to keep one consistent line. Like so, and that is the drawing completed. Again, if I was you, ensure that you've appropriately annotated all the bits of terminology identified. If there's particular constructions happening here, write in what's happening. As well as that, use different colors if you like. You know, for your focal line, use a red and put the focal line in red. Then let's say for the eccentricity line, put a green maybe, and the ECC in green, just to identify the different parts. As well as that, if you want to put, let's say, this construction here, how you identified the focal point in a certain color as well, just to show that that is all related, as well as the arc in that color. It can be very helpful, especially when explaining to students, like on a board or through a projector, where they all have to pick it up straight away. For a video like this, it's not 100% necessary, for the reason that you can actually just move back the video and you can look when that particular construction is being created. But yeah, that's the solution for this question.